Have you ever wondered if vampire stories might have some basis in reality? I'm not just talking about urban legends or the dark tales you hear around the campfire. I'm talking about science, genetics, and the almost godlike power we have to shape human biology. Imagine, for a moment, that we could create superhumans with abilities that until now existed only in the most ancient myths of past civilizations. Beings who feed on blood, defy time, and have a mortal aversion to sunlight. Sound crazy? Well, modern science is closer to that point than you might think, and that's what we're going to explore. While vampire tales have always captured the collective imagination, from tales of monster-hunting heroes to stories of witches and their curses, the truth is that the pursuit of power and longevity is part of our DNA. Today, advances in biotechnology and genetic engineering are opening doors to possibilities that would make even the alchemists of ancient history bow in awe. We are on the verge of mixing the real with the supernatural, with science taking on the role of creator or perhaps destroyer. But before you think that all this is just a fantasy, know that we already have pieces of the puzzle. Genes that regulate aging, enzymes that can prolong youth, and incredible adaptations seen in creatures of nature are all being studied. So the question is no longer if we can create beings with vampire traits, but when and at what cost. And between a promise of immortality and a dark risk, what will be the price to pay? Stay with me, because this journey may change the way you see the future, and who knows, even humanity itself. The idea of humans being able to live off blood is as fascinating as it is frightening, don't you think? Just imagine a being that needs this vital essence to survive, a vampire-like figure, shaped by science and mythology. For this to happen, we would have to modify genes so that they produce antithrombotic substances, something similar to what we find in the saliva of vampire bats. Have you ever heard of Draculin? Well, this protein plays a crucial role in the lives of these small winged predators, keeping the blood fluid while they feed. Translating this logic to human biology, it would require more than a simple adjustment. We are talking about a genetic reconfiguration worthy of the legends and ancient tales that have filled the history of so many civilizations. Now, think about the complexity of our blood, a true elixir of life. It is not just any fluid, but a dynamic system that, at the slightest sign of danger, activates its natural defenses to avoid internal chaos. Adapting the human body to consume blood would require the introduction of genes that not only prevent clotting, but also make the entire process safe and efficient. Our scientific heroes would need to study nature's vampire mechanisms in order to replicate them. The funny thing is that, who would have thought the secrets to creating a modern vampire may be hidden in the darkest corners of a cave full of bats? And make no mistake, transforming vampire fiction into scientific reality is not a simple genetic copy and paste. The human body would need adjustments to deal with the excess iron present in the blood. After all, unlike urban legends, where vampires drink blood like they drink a glass of wine, the real process would require a new approach to avoid damage to the liver and other vital organs. It would be like creating a kind of vampire superhuman, with a digestive system that resembles a cunning sorcerer more than an ordinary human being. This genetic journey is not limited to the modification of one gene or another, but opens the door to the reinterpretation of biology as we know it. Could it be that, in the midst of the search for these feats worthy of ancient civilizations and stories of vampires and witches, more questions than answers arise? And what would the connection between myth and reality be like when we talk about modern heroes and monsters, shaped by science? Perhaps, as you turn this page, you will find yourself wondering, how far can science go to recreate stories that once existed only in nightmares and candlelit tales? The search for immortality. Oh, how many ancient stories and legends revolve around this very human desire? Vampires are perhaps the ultimate representation of this yearning. Figures who defy time, seemingly untouchable by the deterioration that affects mortals. But what does modern science have to say about this? Surprisingly, biology holds secrets similar to those in the legends, and one of them is the FOXO gene, a true key to the longevity observed in hydras, those nearly immortal aquatic creatures. If one day we want to transform the idea of a vampire into something more real and scientific, this gene would be a fundamental piece in the equation. Now, imagine a human being who could regenerate their cells without the limits of senescence, a natural process that dictates aging. The introduction of the FOXO gene into our DNA could trigger a continuous renewal of stem cells, keeping organs and tissues in a constant state of repair. But not everything is so simple, is it? There is a danger in releasing this regenerative force without restrictions. Unbridled cell growth can result in tumors, the dark side of biological immortality. And anyone who has heard of witches and their magic potions knows that all power has a price, even if it is achieved through science. And what about telomerase, this almost mythical enzyme? It is responsible for keeping telomeres, the tips of our chromosomes, intact, prolonging the cell's ability to divide. Over time, as telomeres shorten, our cells lose the ability to regenerate, and old age sets in. Now think, what if we could manipulate telomerase to keep these telomeres forever young? The process sounds tempting, but what is stopping science from creating vampire heroes and eternal beings? The answer lies in the balance, in the razor's edge between longevity and control. And in the midst of all this, a question remains. Is immortality a blessing or a curse? There is a hint of irony here, don't you think? The same path that could give us the vampiric immortality of fairy tales and folklore could also bring us closer to a destiny full of dilemmas. Just like the urban legends about ancient civilizations that sought eternal life, modern science is lurking, on the verge of recreating the impossible. And as we continue to explore these genetic mysteries, it is impossible not to wonder, what comes next? After all, even beings that defy time have their shadows, and perhaps, who knows, a silent fear of the light. Ah, sunlight, so revered by ancient civilizations and feared by the beings of vampire legend. From ancient history to tales of witches and vampires, light has always been seen as a symbol of life and, for some, destruction. In order for superhumans with vampire characteristics to exist, it would be essential to simulate a hypersensitivity to UV radiation. You might be thinking, but is that really possible? Interestingly, we already have real-life examples that may give us a clue. People suffering from xeroderma pigmentosum, XP, cannot expose themselves to the sun without facing severe consequences. Their skin burns and is easily damaged due to mutations in genes responsible for repairing DNA damaged by radiation. Now, imagine a modified version of this condition, but enhanced to replicate vampires' extreme aversion to sunlight. It would be a dark and, at the same time, fascinating spectacle. Genetically modifying humans to have an increased response to UV rays would not be simple, but in theory, it could be feasible. In addition, genes that influence melanin production could be manipulated to create skin that reacts intensely sensitively to light. The result? A vampire-like being that, as in urban legends, would only move under the cover of darkness, avoiding the fatal exposure of daylight. If we dig a little deeper, we will realize that science is already flirting with these possibilities in small details. The vampire aversion to sunlight can be compared, in part, to rare diseases involving photosensitivity. But why would anyone try to replicate something like this in a laboratory? Well, if you are a lover of fantastic stories and the folklore surrounding vampire mysteries, the answer may lie in the simple idea of recreating the impossible, of giving life to that which previously only existed in the shadows of fables told by the fireside. And that is where the plot begins to get complicated. If we can alter genes to create superhumans who mimic vampires' fear of light, what else might we be able to do? And what implications would that have for our understanding of heroism and danger? The line between the real and the mythical, which once seemed so clear, is blurring. Let me ask you, what happens when we start to play with the very foundations of our own biology and get ever closer to what once inspired myth and superstition? The human metabolism is a complex machine designed to process a varied diet, full of nutrients, carbohydrates, and fats. Now, imagine a body that survives exclusively on blood, like the vampires of legends and tales that echo since ancient civilizations. For this to become possible, we would need to reconfigure the human digestive system, introducing genetic adaptations similar to those found in vampire bats. These small nocturnal mammals, known for their vampiric way of life, have lost genes associated with the production of insulin and the perception of sweet and bitter flavors. In a modified human being, the loss or alteration of these genes would be essential to sustain such a particular diet. And it doesn't stop there. In folklore, vampires are known for drinking large quantities of blood without suffering the consequences that a normal human would face. But in reality, consuming too much blood would lead to an overload of iron, which the human body is not equipped to process without problems. Thus, to create a superhuman with vampire abilities, it would be necessary to adapt the digestive system to quickly expel excess iron and maintain homeostasis. It would be like having a stomach that acts as an ultra-sophisticated filter, reminiscent of the adaptations of the vampire bat, which removes water from the blood to keep only solid nutrients. Think of the engineering required to make this a reality. Genetic modification would have to involve not only the genes that control digestion, but also those that regulate the absorption of iron and other minerals. Science would need to draw inspiration from heroes and mythical figures from vampire stories to build an efficient system that prevents damage to the liver and other organs. It is as if a breeze of mystery enveloped genetics laboratories, conjuring up images of witches and alchemists from bygone eras who, in the absence of technology, sought to create magical elixirs to defy the laws of nature. But, as with everything that involves the unknown, this type of experiment opens doors to questions that go beyond biology. If a superhuman could consume blood to survive, what would that say about their relationship with society? Would they be dark heroes or tragic figures, condemned to live on the margins, like the vampires of legend? And what would come after these changes? Would this be the beginning of an era where myth and science walk side by side, blurring the lines between the real and the supernatural? And so, we move on to the next step, where regeneration and longevity take center stage. When we think of vampires from ancient legends, one of the first characteristics that comes to mind is the ability to regenerate, heal wounds almost instantly, and defy aging. This ability, which seems to have come from the stories of ancient civilizations and folklore about immortal heroes, could have a scientific basis in modern biology. And this is where the FOXO gene comes into play, a true maestro of longevity and cell renewal. In creatures like the Hydra, this gene plays the role of keeping stem cells in a state of constant self-renewal, allowing the small aquatic animal to defy the passage of time. Applying this idea to humans would not be an easy task, but it is not an impossible dream either. Studies indicate that increasing the expression of the FOXO gene in human stem cells could increase the capacity for regeneration, delaying the effects of aging. However, like all power, this comes with a price. Overexpression of genes can lead to uncontrolled cell growth, one of the main factors that contribute to the development of tumors. It's like playing with the very essence of life, a dangerous game where the line between regeneration and destruction is thin. Here, modern science meets the stories of witches and beings who sought the secret of immortality in the shadows of myth. And speaking of regeneration, think about the impacts of this on practical life. Imagine a world where injuries no longer left scars, where degenerative diseases lost the battle to a renewing cellular system. We would be heroes of our own narrative, legendary figures walking among mortals. But, as folklore says, with great power comes great dilemmas. Would society be prepared for such a drastic change? And what's more, how should we deal with the ethical aspects of modifying the human essence to create vampiric longevity? After all, even the ancients feared what they could not control, and tales of immortality often came with a note of caution. So if we ever manage to master this art of manipulating regeneration and longevity, we would have a glimpse of what it is like to be a vampire, a walking paradox between heroism and curse. What will we do with this gift? Would it usher in a new era of conquest or a repeat of the tragedies that populate urban legends and ancient stories about the quest for eternity? And before answering these questions, there are still more mysteries to explore. such as nutrient control and the delicate balance of vampire life. If there is one detail that often goes unnoticed in vampire legends, but which has an intriguing scientific basis, it is the issue of blood consumption and the administration of iron into the body. Imagine a being that feeds exclusively on blood, a fluid rich in iron, capable of overloading the common human body if ingested in excess. Vampire bats, which inhabit the shadows of stories and nocturnal tales, have a system adapted to deal with this. In a superhuman with vampire characteristics, it would be essential to adjust the genome to ensure that iron is absorbed and expelled efficiently, avoiding overload and potential damage to organs such as the liver. Genetic modification could include the introduction of mechanisms that regulate the absorption of iron and promote its rapid elimination, as occurs in bats. They urinate immediately after feeding to eliminate excess water and iron, a trick that keeps them light and healthy. In superhumans, adapting this mechanism could involve creating a digestive system capable of processing large volumes of iron without accumulating dangerous toxins. It would be like having a kind of built-in vampire filter, a tweak that would make the blood-eating diet not only viable but sustainable. Iron control would also pose practical challenges. While ancient vampire stories and tales portray these figures as immune to human foibles, in reality, maintaining a healthy balance of iron and other nutrients would be vital to preventing these superhumans from suffering from conditions such as hemochromatosis, a disease caused by excessive iron accumulation. It's interesting how myth intertwines with science here. Even the fiercest vampire heroes need a well-tuned system to sustain their unconventional habits. So the question remains, if we could create humans who drink blood and process iron like a precise machine, what other tweaks would science be willing to make? This discussion leads us to reflect not only on biological viability, but also on the ethical and moral dilemmas involved in creating beings with traits so deeply inspired by vampire folklore. But before we get to these more philosophical considerations, it is essential to explore the ethical and social implications of playing with genetics to create modern legends. Creating superhumans with vampiric traits is not just a scientific endeavor. It is a deep dive into the most intricate questions of ethics and morality. The idea of genetically modifying human beings to become more than they are, something that dates back to ancient legends and tales of heroes and supernatural beings, raises a series of questions. How far should we go in the quest for human enhancement? Modern science, with all its power of genetic manipulation, faces the same dilemmas that ancient civilizations faced when telling stories of witches and alchemists. The desire to transcend mortality and human limitations always came at a cost. Imagine a world where genetically modified people coexist with normal humans. The line between the vampiric hero and the monster becomes blurred, and the social implications could be immense. Would these superhumans be considered superior, forming a new elite? Or would they be seen as aberrations, feared and persecuted, as in the urban legends of monsters and supernatural creatures that inhabit the popular imagination? What is fascinating is that the ethical dilemmas of this discussion echo in vampire stories, which have always been complex beings, often caught between good and evil, between desire and curse. Furthermore, the use of these genetic modifications for commercial or military purposes raises even more serious concerns. Imagine an army of superhumans capable of regenerating, avoiding aging, and surviving in extreme conditions. What was once a vampire tale of supernatural power becomes a real threat to world peace and individual freedom. And even if science manages to balance ethics with innovation, one question remains: how to control who has access to this technology? How to prevent the quest for vampire immortality and other enhancements from falling into the wrong hands, if we can even define the right hands in this context? Ultimately, what began as a journey through biology and science leads us back to the most fundamental human questions. Stories, legends, and myths about vampires have always addressed themes of desire, control, and the struggle against one's own nature. And now, with science potentially achieving the impossible, these reflections are more relevant than ever. When we mix reality with myth, fiction with possibility, we not only open the door to new discoveries, but also to dilemmas that our ancient civilizations already knew well. How far can humanity go before its advances turn against it? Now you know that myth and reality can walk hand in hand. That stories of vampires, immortal heroes, and civilizations that dared to defy death itself are more than mere tales. They are echoes of a deep and ancient human desire. But as we cross that fine line between who we are and who we can become, a disturbing truth emerges. Playing the Creator comes at a price. And when the lights go out and the shadows take over, will we be prepared to face the consequences of our creations?